Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 81. So it says a voltmeter and ammeter can be connected, and as shown in figure A, which is the left circuit I have shown here, to measure the resistance R. If V is the voltmeter reading and I is the ammeter reading, the value of R will not quite be V over I, as Ohm's law states, because some of the current actually goes through the voltmeter, so that the actual value of R is given by that expression. And it says, note that it approaches the V over I for Ohm's law if the voltmeter resistance is really great. Okay, so if we assume the ammeter is ideal and has zero resistance, but the voltmeter has a resistance RV, we can figure out the total voltage here in the equation, or using Ohm's law, it's just I times the equivalent resistance. So this is given as I times just these two resistors in parallel. And now we can rearrange this and solve for what I is, and see that I is V times 1 over R plus 1 over RV. And again, we can divide both sides by V and see that we have I over V equals 1 over R plus 1 over RV. So now we just rearrange this and see that 1 over R equals I over V minus 1 over RV. And that's exactly what we wanted to show. Okay, so part B now asks if a voltmeter and ammeter can also be connected as shown in figure B, which is shown here on the right side, right circuit I have, to measure the resistance R. And it says show, in this case, that R is given as a different expression here, where V and I are the voltmeter and ammeter readings, and RA is the resistance of the ammeter. So now we're going to assume that our voltmeter is ideal, which means RV is infinity. And what this does is it just means we can assume that this branch is not traveled at all by the current. So the total Ohm's law equation will tell you the current times R plus RA, because these two are just in series with each other. So now, from this, all we have to do is divide by I on both sides, and we see that V over I equals R plus RA. And then we just solve for R, seeing V over I minus RA. And that's exactly what we wanted to show. Awesome.